So if my second group is a pair and not on the other side, I return a 1. If it's the other way around, I return a -1. Again, this is this is how the compare to method, the contract of the compare to method is spec'd.
Good morning, everybody. Day 7 of Advent of Code, and my guest today is Achim. Good morning, Achim.
Good morning, Thomas. Hello, world.
So, Achim, please, can you explain us the riddle for today and show us your solution?
Of course. Today we have to play Camel Cards, which is somewhat similar to poker. And as with poker, we have certain cards: ace, king, queen, jack, 10, 9, and so on, down to 2. And as well as in poker, if we have 5 of a kind, we have the strongest hand there is. 4 of a kind, the full house, 3 of a kind, 2 pair, 1 pair. And if we have all cards distinct, then we have just the highest card that might win the day or not. So, and every full house, for those who play poker, it is stronger than just a triple.
Okay, it's very similar to poker.
Exactly. If we have 2 hands which have the same similar composition, we have to check for the first card in each hand. And for that, we are not allowed to sort the cards by value or something like that, but as they are given. That is important. This clarifies it because in this way, the 4-ship of 3 wins out against the 4-ship of aces, because the first card here is a 3 and there is a 2.
This is a different to poker.
This is a bit different. In poker, the 4 aces would win out because they are itself bigger than the 3s. And for each card, we have given a bit value, which is relevant for the evaluation. I first thought we don't need it, but we do need it. For the second part, it gets a bit more wild, because the J's are no longer jacks, but jokers. And as such, they have a lower value, but you can use them as jokers. For example, this, which is originally a 2 pair of 10s and jacks, becomes a 4-ship of 10s.
Okay.
But for the evaluation by card value, these are lower than the 2.
Also for the second ordering, if the first
Exactly.
ordering is the same, okay.
So for the code, first we need to parse it, then sort the hands by their estimated value, and we have to sum them, and we have to take their position and multiply it with a bit value. That is the second part that is given.
Yeah.
This one. And we get a result. That is similar for both parts. The difference is how we process those hands, and I have integrated it directly into my constructor.
So you have both riddles in one code this time?
Yes.
Okay.
So I have here the additional jokers parameter, which I introduced with part 2. So for part 1, the jack represented by J, is a 11. So I map the characters into proper numbers. This maps down the 2s to 9 to values 2 to 9, taking advantage of how the ASCII code is organized. The 10s are 10, obviously. The jacks are 11, the queens are 12, the kings are 13, and the aces are 14. And for part 2, the jacks becomes jokers and so are reduced to 1. So for finding out what groups I have in my card, the constructor also constructs this by value array, where I look onto each card value and increment the corresponding position in this array. This is an idea that I took from counting sort, an interesting sorting algorithm. So if I have 3 cards of the same value, by value would output for that value the number 3. But the joker cards I put on a different stack because they augment the biggest group.
Yeah, but this is for part 2.
That is for part 2.
Let's come to your comparator.
Yes, it's a bit ugly, I have to admit. So from this hand and the other, I take the by value array and sort it. And I also had put in the distinct method, so I only would get distinct values, but that would destroy the 2-pair detection, so I kicked it out again. Which means that in these 2 arrays, the largest group is the last entry. And I access exactly that. Then I build the difference of them. And the one that is bigger would then be returned, which is in the contract of the compare to method. But if this is 0, then the biggest group of both hands have the same size. And in that case, if the biggest group is of size 3 or 2, I turn to the second biggest group. Because if I have a pair there, then I either have a full house or a 2-pair. I can do it this way because if the biggest group size would differ, the method would have already returned here. So I can just look on one side.
Understood.
Because the other side has the same size. So if my second group is a pair and not on the other side, I return a 1. If it's the other way around, I return a -1. Again, this is how the compare to method, the contract of the compare to method is spec'd. And if that all doesn't bring a decision, I then go through both hands, card by card, and compare them. And if I have a difference, I return that and I'm done. If they are completely the same, by contract, I have to return a 0.
Only in your for loop, you use directly the hand as it is. And before
Exactly.
you have your 2 groups and you compare you both groups. Okay, I got it. What was the hardest thing, the biggest challenge for you in this riddle?
My own stupidity by first completely ignoring that there's a 2-pair rule. And then when adding the jokers, I had a minus here instead of a plus.
Ah, okay. Yeah. Cool. Other words to this riddle?
It took me some time, but it's somehow nice.
Yeah, I like it also. Then, Achim, big thank you to you. I hope you liked to watching this video. And yeah, we see us tomorrow. Bye-bye.
Bye-bye.